Hello again, everyone. This time we're going to discuss equations involving complex numbers and absolute value equations. I am Catherine I. Merca from the Department of Mathematics and Statistics. Our learning objective is for you to be able to learn how to solve equations involving complex numbers and absolute value equations. In solving equations involving complex numbers, we use the definition that a plus bi equals c plus di if and only if a equals c and b equals d. The complex number is basically the combination of a real number and an imaginary number. The complex number is in the form of a plus bi, where a equals real number and ib equals imaginary number. Also, ab belongs to real numbers and I equals square root of negative 1. So that in this case, c and d are also real numbers. Hence, a complex number is a simple representation of addition of two numbers. That is, real number and an imaginary number. One part of it is purely real and the other part is purely imaginary. Example, find the solution set of the following equations. 2 minus 5i equals 4 plus 2i, quantity z. Number 2, z plus 5i over z minus I plus z minus 2i over z plus I is equal to 0. So let us solve example number 1. So first, we have to solve for z. The given equation is 2 minus 5i equals 4 plus 2i times the quantity z. So that we have this time, to isolate z, we divide 4 plus 2i z by 4 plus 2i and divide 2 minus 5i by 4 plus 2i. And we have the following, that is, z now equals 2 minus 5i over 4 plus 2i. The next step is to write z in the standard form a plus bi. And we do this by multiplying both the numerator and denominator by the conjugate of the denominator. So from z equals 2 minus 5i over 4 plus 2i, note that the conjugate of the denominator 4 plus 2i equals 4 minus 2i. Thus, we now have the following. That is 2 minus 5i over 4 plus 2i times 4 minus 2i over 4 minus 2i. Notice that this is just equal to 1. So when we multiply this quantity by 1, we still have the same value. That is equal to 2 minus 5i times 4 minus 2i over 4 plus 2i times 4 minus 2i will give us, we have 2 times 4 is equal to 8. Then minus 5i times 4 is actually equal to negative 20i. And then we have 10 comes from the value minus 5i times minus 2i. That is equal to positive positive 10i squared. But I squared is equal to negative 1. That's why we have negative 10 here. And then we have now 4 plus 2i times 4 minus 2i. When you square that one, that becomes 4 squared minus 2i squared, the quantity 2i squared. But 4 squared is 16 and the quantity 2i squared will give us 4 times negative 1, that is negative 4, and the negative of negative 4 will give us positive 4. 8 minus 10 will give us negative 2, negative 20 minus 4 will give us negative 24. That's why we have negative 24i here, and we have 16 plus 4 is equal to 20. So meaning to say here, z is now equal to, we have, because negative 2 divided by 20 is negative 1 over 10, and negative 24i divided by 20 is equal to negative 6 over 5i. Therefore, the solution set is the set containing negative 1 over 10 minus 6 over 5i. So here's our second example. So the first step is to get rid of the rational expressions by multiplying both sides of the equation by the LCD. In this case, the LCD is z minus I times z plus I. So that we now have the following: z plus 5i over z minus I plus z minus 2i over z plus I. Since the LCD is z minus I times z plus I, we multiply both sides by this quantity and come up with the following. Z minus I cancels out with z minus I here. So we are left with z plus I times z plus 5i here. Plus, again, we have z minus I times z plus I. But z plus I here cancels out with z plus I here. So we have z minus I, this one, times z minus 2i, which is equal to, on the other side, we have 0. Therefore, if we simplify this further, we have z times z will give us z squared. 5iz plus zi will give us 6iz. And you have positive 5i times I will give us positive 5i squared. But since I squared is negative 1, so we have here negative 5. And then this one will give us z squared, z times z. And then minus 2iz. And then we have minus iz, so that will give us minus 3iz. Then minus 2i times minus I, that will give us positive 4i squared. I'm sorry, positive 2i squared. But since I squared is equal to negative 1, that's why we have negative 2 here. It's equal to 0. So that when we simplify this further, we now have the following. We have z squared plus z squared will give us 2z squared. 6iz minus 3iz will give us positive 3iz. Minus 5 minus 2 will give us minus 7. So the resulting equation is quadratic equation in z. So if we try to solve the equation 2z squared plus 3iz minus 7 equal to 0, this time using the quadratic formula. If you remember, the quadratic formula is given by the equation minus b plus or minus square root of b squared minus 4ac all over 2a. So from here we have a is 2, b is 3i, and c is equal to negative 7. So again, using the quadratic formula, is our quadratic formula here should be the following. You have, since our b is 3i, so minus b will be minus 3i. Minus b plus or minus square root of b squared. So 3i squared minus 4a is 2, then c is negative 7. All over 2a. So 2 times 2, our a is 2 here. So simplifying further, we have 3i plus or minus square root of 3i squared to give us 9i squared, but I squared is equal to negative 1. So you have 3 times negative 1. 3 squared times negative 1 will give us negative 9. 4 times 2 times negative 7. Then we have a negative here. So we have positive 56. So the result is 3i plus or minus square root of negative 9 plus 56 all over 4. Meaning to say, we have z equals negative 3i plus or minus square root of 47 all over 4. So that our solution set is now minus 3i minus square root of 47 over 4 and minus 3i plus square root of 47 over 4. An absolute value equation is an equation which involves absolute values. That is, some expressions are contained within the absolute value. If you recall, an absolute value of a number is simply the distance of that number from the origin on the real number line. Thus, for a real number x, the absolute value of x this time is defined as follows. That is, the absolute value of x equals x if x is greater than or equal to 0, negative x if x is less than 0. Thus we see that if x is a real number, then the absolute value of x is always greater than or equal to 0. So if x is less than 0, then there is no solution. For example, the equation absolute value of x equals negative 1 has no solution. Moreover, if we have an equation absolute value of x equal to a, where a is a real number, this means that we find those number x on the real line which are at a distance a units from the 0. So how do we solve absolute value equations? Here are the steps. Step 1 is to write the given equation into the form absolute value of u is equal to a, or absolute value of u is equal to the absolute value of a, where u and a be algebraic expressions. And then apply the following theorem to the equation obtained in step 1. That is, we let u and a be algebraic expressions. Then, if the absolute value of u is equal to a, then u is equal to a, or u equals minus a. Absolute value of u is equal to absolute value of a if and only if u is equal to a, or u equals minus a. Solve each of the equations u is equal to a, or u is equal to minus a. Check the value obtained in step 3 by substituting the number to the original equation. So we now try to solve the following absolute value equation. So example 1, find the solution set of the following. Number 1, x minus 1, absolute value of x minus 1 equals absolute value of 2x plus 5. We have 1.2, that is, absolute value of x plus 1 over x minus 1 is equal to 2. 1.3, we have absolute value of y minus 3 minus 2y squared is equal to 0. So we now try to solve the absolute value of x minus 1 equals the absolute value of 2x plus 5. So write the given equation into the form absolute value of u is equal to a, or absolute value of u is equal to absolute value of a, where u and a be algebraic expressions. In this case, we make use of the following. That is, the absolute value of u is equal to absolute value of a because it is of this form. So that this equation can be solved as follows. Apply the following theorem to the equation obtained in step 1. So you now have here absolute value of u is equal to absolute value of a. If and only if u is equal to a, we remove the absolute value sign there, is equal to a. Or u is equal to, again, remove the absolute value sign there, negative a. So if u is equal to a or u equal to negative a, as defined earlier. And then we have the following: x minus 1 equals the absolute value equals the absolute value of 2x plus 5. Applying the theorem, we have x minus 1, you remove the absolute value sign there, equals 2x plus 5, it's positive, okay, just like what we have here. And then, or x minus 1, this time the negative of a, which is here 2x plus 5, that is negative of 2x plus 5. And then we solve each of the equations u equals a or u equals negative a. That is, for x minus 1 equals 2x plus 5, we have the following. X minus 1 equals 2x plus 5. We can rewrite it as x minus 2x. And then we have 5 here, so then we have minus 1. We have x minus 2x will give us minus x. 5 plus 1 will give us 6. And then we have negative x divided by negative 1. So divide both sides by negative 1. We come up with x equals negative 6. For x minus 1 equals the quantity minus 2x plus 5, then we have the following. That is, x minus 1 equals the negative of the quantity 2x plus 5. We can distribute the negative sign here and come up with minus 2x minus 5. Then x minus 2x here, so it becomes plus 2x on the other side. Then minus 5, then we have minus 1, so it becomes plus 1 here. So 3x equals minus 4. 3x divided by 3. So we also divide the other side by 3. We come up therefore with x equals minus 4/3. So the last part would be to check the value obtained in step 3 by substituting the number to the original equation. So this is the original equation. Absolute value of x minus 1 equals absolute value of 2x plus 5. When x equal to negative 6, we have the following. That is, the absolute value of x minus 1 equals absolute value of 2x plus 5. So replace x by negative 6. So negative 6 minus 1, absolute value. Then you have 2 times. Replace x here by negative 6 plus 5, absolute value. That should give us negative 7, absolute value. And the absolute value of negative 12 plus 5. But that comes up to be the absolute value of negative 7 equals the absolute value of negative 7. And we know that that is actually equal to 7 over 7, which is true. Then when x equals negative 4 over 3, we have the following. That is the absolute value of negative 4 over 3 minus 1. So we replace actually our x here. This is our x here. With negative 4 over 3. And then replace again our x here with negative 4 over 3. So you have 2 times negative 4 over 3 plus 5, that its absolute value, which will give us the LCD for this is 3. So we have here 3 times negative 1 will give us negative 3. So negative 4 times negative 3, negative 4 minus 3 will give over 3 will give us negative 7 over 3 equals negative 8 over 3 plus 5 here. So the LCD is 3 again, so 3 times 5 will give us 15. So the absolute value of negative 8 plus 15 all over 3 is equal to positive 7 over 3. On the other hand, this is negative 7 over 3, but that is actually equal to the positive value of 7 over 3 and we also have equals 7 over 3, which is indeed true. Therefore, the solution set is the set containing negative 6 and negative 4 over 3. Observe that if we remove the absolute value of the expression in the right side of the equation, absolute value of x minus 1 equals 2x, absolute value of 2x plus 5, we have absolute value of x minus 1 equals 2x plus 5. Now, if we find the solution set, absolute value of x minus 1 equals 2x plus 5, then x minus 1 equals 2x plus 5, or x minus 1 equals the negative of the quantity 2x plus 5. Thus, x equals negative 6 or x equals negative 4 over 3. You can take a look at example 1, steps and solution. However, one can verify, or you may also again see example 1, step 4, that only x equals negative 4 over 3 is the solution of the equation absolute value of x minus 1, which is equal to 2x plus 5. So meaning to say, it is very important to check the values we obtained in step 3 by substituting those numbers to the original equation. So we now solve the equation absolute value of x plus 1 over x minus 1 is equal to 2. So we have to write the given equation into the form absolute value of u is equal to a, or absolute value of u is equal to a, where u and a are algebraic expressions. Now this given equation is already in the form absolute value of u is equal to a. This one, if you take a look, it's already, your u there is x plus 1 over x minus 1, and our a is 2. So we have to apply the following theorem to the equation obtained in step 1. That is, we let u and a be algebraic expressions, wherein we have, if you have absolute value of u is equal to a, then you come up with, get rid of the absolute value sign there, u equals a, or again you have u equals, this time, minus a. So from this, we now can rewrite the absolute value of x plus 1 over x minus 1 equals 2 as follows. That is, applying the theorem, we have x plus 1 over x minus 1, we get rid of the absolute value sign there, equals 2, or x plus 1 over x minus 1, again we get rid of the absolute value sign there, equals, this time, negative 2. And then solve each of the equations, u equals a or u equals negative a. So for x plus 1 over x minus 1 equals 2, we have the following. That is, we have x plus 1 over x minus 1 equals 2. We get rid of the fraction by multiplying both sides by x minus 1. So we have now x minus 1 and x minus 1 cancels out here. So what is left is x plus 1 equals 2 times, you have x minus 1. And then distribute 2 on the other side. So we have 2x minus 2. And then you now have x, combine similar terms. So you have x minus 2x. Then you have 1 here. So we will have negative 2 minus 1. So what is left here is negative x. That's equal to negative 2 minus 1 is negative 3. And then divide both sides by negative 1 to come up with x equals 3. Now on the other hand, for x plus 1 over x minus 1 equals negative 2, we have the following. So that x plus 1 over x minus 1 equals negative 2. Similarly, we can multiply both sides by x minus 1 to come up with equals negative 2 over x minus 1 on the other side. And then x minus 1 and x minus 1 cancels out here. So you are left with x plus 1 minus 2 times quantity x minus 1. Distributing negative 2, we have negative 2x plus 2 on the other side. And combining similar terms, you have x plus 2x here, because when you transpose 2x on the other side, minus 2x becomes plus 2x. And on the other side, you have 2 here, minus 1. Okay, transpose 1 on the other side. You will have 3x equals 1, or 3x over 3. This time we divide both sides by 3 to come up with x equals 1/3. Now, the last part would be to check the value obtained in step 3 by substituting the number of the original equation. So this is the original equation, the absolute value of x plus 1 minus x minus over x minus 1 equals 2. When x is equal to 3, we try to substitute the value. So what do we have here now? We have the following, that is, the absolute value of x plus 1 over x minus 1 is equal to 2. So substitute 3 to x, we will have 3 plus 1 over 3 minus 1, its absolute value, which will give us 4 over 2. Absolute value of 4 over 2 is 2. So meaning to say this is actually true. On the other side, we have x equals 1 over 3. So when we substitute x is equal to 1 over 3 to the original equation, we come up with the absolute value of 1/3. 1/3 replaces your x, plus 1 over 1/3, again replaces x here, minus 1. Is that indeed equal to 2? So when we take the LCD of 1/3 and 1, we have 3 there. So 1/3, and then you have actually 3 times 1, so that's why you have 3. So 1 plus 3 will give you 4 over 3. On the other side, this is 1 over 3 minus negative 1. So you will have 3 here as your LCD. And you have 1 minus 3. So mean to say, you have 4 over 3, and you have negative 2 over 3. But that can be simplified into 4 over negative 2, because your 3 over 3 there cancels out. So the absolute value of negative 2 is indeed equal to 2, meaning to say the result is also true. And because of that, we now have our solution set, which is equal to 3 and 1/3. So it's the set containing 3 and 1/3. Now we have example C, the absolute value of y minus 3 minus 2y squared equal to 0. So the first step would be to again write the given equation into the form absolute value of u is equal to a, or absolute value of u is equal to absolute value of a. In this case, we make use of the first form, which is absolute value of u is equal to a. So that when we rewrite absolute value of y minus 3 minus 2y squared equal to 0, we can simply add both sides by 2y squared and come up with absolute value of y minus 3 equals 2y squared. So we now apply the following theorem to the equation, that is, absolute value of u is equal to a, then u is equal to a, or u equals minus a. So from there, we now have the following, that is, absolute value of y minus 3 equals 2y squared. So come up with, can now write that one as, you have y minus 3, you get rid of the absolute value sign there, equals 2y squared, or y minus 3 equals the negative of 2y squared. And then solve each of the equations u equal to a or u equals minus a. So for y minus 3 equals 2y squared, we have the following. That is, y minus 3 equals 2y squared. So we can now add both sides by minus y plus 3. So minus y plus 3, this becomes 0 on the other side. So we are left with 2y squared minus y plus 3 is equal to 0. And now we can make use of the quadratic formula with a equal to 2, b equals negative 1, c equal to 3. And we have the following. If you remember again, the quadratic formula says you have y equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So we now replace b there with negative 1, so minus of minus 1, plus or minus the square root of negative 1 squared. So that is actually our negative b squared minus 4, our a is 2, and our c is 3, all over 2a. So that's why you have 2 times 2. And then simplifying this one further, we have 1 plus or minus the square root of 1 minus 4 over 4. That's equal to 1 plus or minus the square root of 1 minus 23. That will give us square root of negative 23 there, all over 4. And since negative square root of 3, our square root of negative 23, okay, since square root of negative 23 is not a real number, then so is the value 1 plus or minus square root of negative 3 over 4. Thus, y minus 3 equals 2y squared does not have a solution. For y minus 3 equals negative 2y squared, we have the following. That is, y minus 3 equals negative 2y squared. We can actually add both sides by 2y squared. So we will have 2y squared plus y minus 3 equals, this becomes 0 here. And then factor it if it's factorable. Notice that these are the factors. That's 2y times y will give us 2y squared. 3y plus negative 2y will give us y. And then 3 times negative 1 will give us negative 3. That's our FOIL method if you remember. So we will have 2y plus 3 equal to 0, or y minus 1 equal to 0. That means to say 2y is equal to, when you add both sides by negative 3, so that is 2y equals negative 3. And then on the other side, when you add 1, you will have y is equal to 1. So continuing further, we can divide both sides by, on the first equation here, by 2 to come up with the following. That is 2y over 2 equals negative 3 over 2, meaning to say y is equal to negative 3 over 2. Or, in this case, y is equal to 1. So, we now check the value obtained in step 3 by substituting the number to the original equation. So, this is the original equation. Absolute value of y minus 3 is equal to 2y squared. So, when y equals negative 3 over 2, we have the following. That is, absolute value of negative 3 over 2 minus 3 equals 2 times, you substitute again, 2y, negative 3 over 2, so you have raised the second power. The LCD here is 2, that's why you have minus 6 here, because that's 2 times 3. 2 times negative 3 will give us negative 6. So the result here is negative 9 over 2. On the other side, you have 2 times the square of this is 9 over 4. We have 9 over 2 there. Now this is true, so y equals negative 3 over 2 is actually a solution. On the other hand, when y is equal to 1, we have the following. 1 minus, from here you have 1 minus 3, absolute value equals 2 times 1 squared. You have negative 2 is equal to 2 times 1, which is actually true. So in this case, the solution set is the set containing, we have here negative 3 over 2 1. And now we have our summary and conclusion. That is, if x is an element of R, then the absolute value of x is greater than or equal to 0 by definition of absolute value. And in solving equations involving absolute values, the following theorem is useful. Let U and A be any algebraic expressions. Then, the absolute value of U is equal to A implies U is equal to negative A or U is equal to A. Number 2, the absolute value of U is equal to the absolute value of A if and only if U is equal to A or U equals minus A. So in solving equations involving complex numbers, we use the definition that a plus bi equals c plus di if and only if a equals c and b equals d, where a, b, c, and d are real numbers and the square root of negative 1 is equal to I. For our references, we have the following: Blitzer, College Algebra Essentials, the 5th edition, Pearson, and Algebra and Trigonometry from the Department of Mathematics and Statistics, Mindanao State University, Iligan Institute of Technology, Iligan City. So good day everyone. That ends the first part of our lesson, and then tomorrow we'll discuss other topics.